A very good morning, sir. I'll be making a brief presentation on geology and mineralization just to refresh the geology and mineralization of OGP Block-6. So, just now, there are two cratons. There are two cratons, the Bastar craton in the northeastern part and the Dharwar craton. Okay. The Dharwar craton on the southwestern part separated by Pranita Godavari Rift. Yeah. Okay. These two cratons and the intercratonic area, very interesting. So we are expecting a lot of new geology, new information from this magnetic and radiometric data set. It's going to add a new dimension to our geological understanding and the geology, whatever we evolved till now. The Archean units are mostly the TTG suits and supracrustal belts. The Dharwar, Bengpal, Sukma and Bailadila, they are set in a TTG suit, and there is a Archean mafic ultramafic complex, that is Chimal part in the southern area, this portion, and the Dongargarh network, Paleoproterozoic, it is over here on the east of Gadchiroli, and it forms the core of Bailadila belt over here. And there are granulite belts, Bhopalpatnam, Karimnagar, they are there in both the cratons, the Karimnagar belt and the Bhopalpatnam on the Bastar side. So Dharwar, Bastar craton juxtaposed but separated with a rift basin, Perbo-Carboniferous Gondwana sediments. Then Eastern Ghat mobile belt, a small portion in the southeastern portion, we have Eastern Ghat mobile belt. We don't know exactly on the surface, there is no any signature on the propagation or continuity of the Eastern Ghat mobile belt. That's one very interesting area. As we know, two Archean nuclei, they are juxtaposed and separated by a younger rift basin. So definitely we do expect there could be some erosion between these two cratons. This data is likely to throw some information on it. And of course, we have the Mesoproterozoic Pakhal sediments on the either side of the Pranita Godavari Rift Basin. And here we have Penganga, Neoproterozoic, and some Deccan traps over all these. If we see sequentially the Archean rocks, TTG suits with the Bengpal supergroup, Bengpal group, Dharwar supergroup over here, and Sukma high-grade supracrustals. They all cover the Archean rocks. Here, Bengpal, Dharwar, Sukma, and the Chimpal part, Cabro anorthosite complex. Then Archean Proterozoic, we have TTG suit, PGC2, and the Bailadila over here, and Bhopalpatnam granulite belt and Eastern Ghat mobile belt portion, just north of Vijayawada. And these form Archean Proterozoic rocks, and this is the Dongargarh granite, Paleoproterozoic Dongargarh granite. It forms the core of a Bailadila belt, and the Pakhals. These are the Mesoproterozoic basins on the either side of Pranita Godavari, followed by Penganga Neoproterozoic formations. Here we have limestone, lots of limestone leases we have in Penganga. We have sandstone and shale. These are the sedimentary. They are Neoproterozoic. Then Permo-Carboniferous Gondwana sequence, northwest, southwest. We have some Lamatas, late Cretaceous, and the Deccan Traps over here, a smaller area just south of Chandrapur. So this is the geological setup, the lithology age units. Now when we look slightly deeper into the supracrustal belts, mafic, ultramafic suits, so we have, and these can be quite well picked up in our magnetics and also the surface geology by radiometrics. These are very important to look for noble metals and the critical minerals. Here, these are the portions, bilateral where BIF's mafic ultramafic suit we have, the superior type BIF. It's very important for us, not only to iron, we can look for gold, and the mafic ultramafics, mostly amphibolites, Bengfall mafic suit, they are there as small enclaves within the TTG suit, and the high-grade supracrustals, Sukma, pyroxene granulites, 2-pyroxene granulites, we have, these are the Sukmas, and again the Bengpal suit is spread all in the Bastar craton over here in the NAGMP Block-6. The predominant lithologies are BMQ and amphibolite. This is gabbro-anorthosite complex. This complex is also very important. The magnetics can pick up any variation within the mafic ultramafic complex, clubbed with its depth continuity, the kinematics, and it is very important for, as we know, nickel, PGE, cobalt, vanadium. So this is also very important complex to see its signature in the new data sets. And we have small patches of dharwars, BIFs and metavolcanic rocks, and some chloride schist in the Dharwar craton, the southern side of the Pranita Godavari rift. And here is a Karimnagar granulate belt over here. And these are the areas they attract us to understand their strike continuity and their structures, and to look for the noble metals and the critical minerals. And these are the cover sediments, which they mask all the Precambrian basement, the Proterozoic basins, mostly the Pakhals here. Of course, the Cretaceous Deccan Traps, the Penganga. Almost 30 to 40% of the areas is covered with the cover sediments. And understanding the geology below cover sediments, and also within the sediments, the variations, the structures, it's expected to be well picked up by our magnetic breaks, and maybe we can add more and more information, and that's going to improvise our understanding on the geology of the cover sediments. And we can do lots of new exercises, like what's there below these sedimentary basins. With the long wavelength anomalies, we can pick up the basement features. We can go very close to making a predictive geological map, predictive structures. So adding new information to our existing geological database is very important to understand geology, and it makes the way go to our deposits, new deposits in the greenfield areas. Okay, yeah. Next. It's not working. Oh yeah. So when we look at the critical minerals, if we start from, say, REs, the potash-rich granitoids, they are important. Here, the mapped areas in the PGC suit, they have been classified that they are potash-rich granitoids. So our radiometrics, the thorium and potassic signals in our radiometric map, it's going to highlight, and even we expect we can see some zoning, we can see concentration along certain zones, the structural lineaments. And these are the areas which are going to be important to look for secondary RE. And of course, we can link the primary and secondary together. And these are the important areas. The north one is the Dongargarh granitoid. We can understand the pulses of granitoid emplacement with the new data set, and we can bring the inhomogeneity or maybe the new homogeneity within the PGC suit part of Dharwar Craton. So these are all going to be very important. As we know, some of the rare earth minerals, they are magnetic. So not only in radiometric map, even in the magnetic image, we are likely to get some better highlights on the magnetic rich portions within the acidic suit. They could be very important to look for RE minerals. Like samarium, neodymium, they are really magnetic. And if there is a better concentration, we can have a look on the secondary enrichment, or maybe with our field investigations and characterizing the regolith or a primary rock, we can get more information on it. And the lanthanoid series, they are mostly magnetic. So it's not only magnetite, there are RE minerals. They also help us in understanding the high magnetic zones. The magnetic and radiometric together, it's going to give us new areas, potential to look for RE mineralization with a ground validation, sample collection, both in the primary environment, secondary regolith, the mechanically broke down primary RE bearing minerals we can pick up in the secondary, if it is chemically disintegrated, and maybe in the clay ion absorption. So we expect a lot in such areas to look for RE from the combination of radiometrics. And of course, the mafic ultramafic suit is so important. Most of our critical minerals listed in Government of India's publication, we have these in the mafic ultramafic system. There are lots of challenges because in the past, mapping has been completely done, and the hashed portions here, large-scale geological mapping has already been done by Geological Survey of India. The past. So lots of ground data is available. Now we are looking on a 50K map. So when we see 10K map, put all our high resolution data into it, do recycling, and with the reinterpreted information, we can go to new places. So characterization of regolith for RE, and mapping igneous pulses is very important thing that we can do it with our radiometric and magnetic, both. There are lots of dikes concentrated, both in the Dharwar as well as in the Bastar Craton. So factoring and kinematics of the dikes can get a better understanding on how do they behave at shallow and deeper levels. These are the areas where we can do the modeling by using and they can be very well picked up in our magnetics. So lots of dikes, and we do see some of the dikes, they abruptly terminate across. Maybe they are partially concealed, or they are not exposed, or they could not pick up in the geological mapping, because some of them, they just terminate across topocean boundaries. So now we can update our geological maps. The radiometrics help a lot in mapping the small lithologies. The magnetics will help in tracing the dikes and intrusive rocks. So these things can be done with and we do expect a lot we can do. And apart from these LSM areas, integrating new data sets and looking together, lots of gap areas. Here nothing has been done yet, no large scale mapping. All these areas are going to open up new places to look for minerals. And characterizing of fault. See, there are number of faults within the white ones. They are the faults picked up in the field studies in the Gondwana. Now with the magnetic breaks, we can pick up even more, and we can do factoring. Adding more structural information will lead us to understand the basin better. Again, the continuity of Eastern Ghat Mobile Belt signatures, maybe towards the Pranita Godavari Rift. That can be interesting part. Maybe this magnetics will give us lead on it. And of course, with radiometrics, we can fine-tune our geological maps. We can update our geological maps by our field geology, asteroid alterations, and magnetics all put together. There is lots of scope in this 76,000 square kilometer. We are going to add lots of, and of course, discovery is a challenge because lots of work has been done with surface manifestation now. Anything subsurface manifestation and the minor concentration of minerals, high value, low concentration, like REs, if we fail to pick up those in our field mapping, now these are the new data sets we expect, at least we go close to the RE mineralization here. So, in terms of mineralization, there are some resource-bearing blocks developed here for copper, Tranavasna. About 20 kilometers south, there is one Dubarpet resource-bearing copper block, Ghote, and here in Dharwar Kritan, Mailaram, they are the places where hydrothermal copper has already been established. And of course, iron ore in the Bailadila as well as in some portion of Dharwar. Iron ore has been, iron ore blocks are there. And there are mining leases. The blue colored ones are the mining leases of limestone, mostly in the Penganga. That was, and lots of occurrences are reported in South Karimnagar, molybdenum, in our previous reports. And kimberlites over here, there are two clusters, lamproid kimberlite bodies. The magnetics and radiometrics, they are really wonderful. If our 300-meter line spacing crosses over the 30 or 50 meter wide lamproid kimberlite, that could lead us a better area to look for, and lots of analysis Dr. Martin will be sharing, and it's going to be very interesting. And we can trace lots of structures within the basin, boundaries, and the shear controlled copper, hydrothermal shear controlled copper, its continuity, and generally they occur in clusters. These areas are going to be very interesting to see all the data sets. Of course, the Gabbro anorthosite Chimpalpada complex and the mafic bodies over here, magnetics are wonderful. They'll give us a lot. The depth continuity, their pulses, we can understand them better, and our fieldwork is going to be very precise to look for certain units which are very important for these mineral systems. So I have listed some mineral systems. They could be very interesting by integrating this data into our already known data. So here I conclude. Thank you for patiently. Thank you.